this. We have a point now where we recognize linear over irreducible quadratic. We know we learned a technique to do this, and so we go and implement that technique. Now, on the previous problem, the one we just did a minute ago, where the suggestion was to split this into two, right? Split this into two. If you look back in our things that we covered earlier, right? Where is it? There we go. So back in our notes, the problems we did at the beginning, I said, hey, if we have a constant over a quadratic where we're missing the x term, we know how to handle that. And that was formula 17. So that's why splitting this made perfect sense, because then we would get, oh, sorry, this one. Splitting this, we get a constant over this. That looks like this. And so that's the path we want to go down. Then the other side is just a basic U sub. All right. We have completed the problems on here. I think what I'm going to do right now is I'm just going to pull up an old test, and I'm just going to see what kind of problem I've thrown on a test. And let's see what we do, or how we do with it. Everyone's all quiet now. God damn it. Exams, ooh. There we go. Let's do that one. All right, let me write it down over here. X squared plus x minus 12. All right, there we go. Y'all are funny. All right, let's go. So we look at this. I see a rational function, right? So I immediately am going to go power here, power here. Long division is where I'm starting. All right? I'm going to start with long division. And is there some other abstract way that maybe I could somehow do this? Maybe, I don't know. But I mean, I'm just trying to get through this. I'm going to go with what, you know, the normal path is here, which is to start with the long division. X cubed plus 2x squared minus 10x. No gaps, right? I don't have any gaps in here? Okay, x squared plus x minus 12. All right. Do this long division. Got to turn x squared into x cubed, so multiply by x. Multiply through. All right, please check that. Does that look right to you? Passing an x through to everything?
Should we do it with the biggest? Always try to find it for x3. Sorry.
We're trying to turn that into that.
Yeah.
So we multiply that by x.
Okay.
And then we distribute here, 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 and put them underneath. And then change the signs. Don't forget that step, right? And then add down. X squared what? Plus 2x. And then, don't forget this one right here, right? Minus 1 just comes down. So now 1. I have to turn x squared into x squared, so plus 1. And then multiply that through 1 times all of those. Subtract. And then add down, you should just get x and then plus 11. There we go. So that's my remainder. So now I have this integral. I'm going to have the x plus 1 in here. Those I'm happy to see. I can integrate those Straightforward, right? And now I'm going to look at this. I've got my remainder, x plus 11, over my divisor. Wait a minute. What? Yeah, this is my remainder, right? Yeah. Over my divisor, like that. Let me go one more step before we do anything else. 1/2 x squared plus x. Those are the antiderivatives of those two, respectively. And then plus here, x plus 11 over x squared plus x minus 12 dx. Okay. Now, at this point, I look at what I have here. I see linear. I see a quadratic, right? I ask myself, is this factorable or not? Is it reducible or not? It is reducible. Since it is, I'm going to do that. I'm not going to use the other method from the previous problem. I'm not going to do that because I can actually factor this. Now, I also maybe just want to check real quick. There's not like a real quick, it's not just a basic u sub, right? Like if I let this be u, what's the derivative of that? 2x plus 1. I don't have that up here, right? So I'm going to proceed with what I thought it was going to be. But I did check that just to make sure, because I would hate to do all this work to find out I could have just done a basic u sub right here.
How did you do u sub that fast? Or check for u sub that fast?
I just said, if this is u, if that's u, what's the derivative of that? 2x plus 1, is that what I have up here?
No.
Yeah, so it's just a quick check. All right, so now I'm going to factor the denominator. Let me continue this. So x plus 11, and then this, x plus 4 minus 3, x4, okay. And the whole purpose of that is to partial fraction now, to go to partial fractions. So now partial fraction decomposition. I write x plus 11 over x plus 4 times x minus 3. And that is going to turn into what? A over x plus 4 plus b over x minus 3. Because I have two linear factors down here, it's going to turn into each of those linear factors will have some constant on top of it, and I'll have two of them. Now I clear the denominator, right? So I multiply the left side by that and the right side by that. I think I'm just going to go right to it. So I'm multiplying here by x plus 4, x minus 3. And then over here, same thing, x plus 4 times x minus 3 goes away. That gives me this. And then here I have to distribute. This one, we're almost there. I mean, like we got a few more steps and we're there. What goes away here on this first multiplication? X plus 4. So I'm left with an a and x minus 3. Good. Next one, b, and then x plus 4. How would you all approach this now? Okay, so go after the a and b directly by letting x be whatever number kills off those factors. So I normally like to go after the a first. So I'm going to kill this one off. So I'm going to let x be what? -4? If I do that, the left side becomes 7 equals a times -4 minus 3 is -7. Oh, hey, look. A is what? -1. This was a test problem, okay? So I made that number nice, right? There weren't any fractions there. Next, let x be, I'm going to go after the b now. So I'm going to let x be 3 to kill this factor. Three is in there, 14, and b times 7 So B is 2. All right, we're almost there. We're almost there. This integral now, right, this one right here turns into, let me just write my answer so far. I have equals, I had the 1/2 x squared, don't forget we had this from before, plus x, plus we need to do the integral. This has all broken down to be a over that. A was -1. So we have -1 over x plus 4. And then we still need to do plus b, but b was 2 over x minus 3 dx. So 1/2 x squared plus x, and each of those are natural logs, right? So minus natural log of x plus 4, and then plus 2 natural log of x minus 3 plus c. Yes?
Is it okay if we show them just like that?
If you do what?
We don't have to like split it into individual.
Oh no, yeah, because you're doing, it's like differentiation, right? When you differentiate, if you have sums and differences, you just do them individually. So that's what I'm doing here. I'm just doing antiderivative, antiderivative, done. All right, let me see. That one was, it was a test problem, so that was pretty clean, yeah?
Yeah, it was easy.
Let's try that one. Let's try that one, but ignore the infinity thing. Ignore the infinity thing. Let's just, let me write it down over here. Oh, 2x squared. We have not needed our calculators yet, have we? We have not. Did I tell you all that story about that professor that I had that didn't talk or didn't like even turn around? Did I tell you all that story?
No, let's hear it.
So yeah, it was a professor of mine. I won't mention who it is because you never know, right? And I'm on camera. But he would go in there. He turned out to be one of my favorite professors of all time because he would go in there and all he would do is he had his own notes, and he would just. I mean, I used to joke around because he wrote so fast that this is what it looked like to me as a student. This is what it looked like he was doing because he was writing so fast. It looked like he was doing this. That's how fast he wrote, right? So you would just go to class and you just sit there and you just write it all down, and then you go home and figure it out. Because I mean, it was graduate level, class or like junior, senior level math classes. So all he was doing was like sharing his knowledge and his organization of the ideas, right? So it was our job to go sort it all out. So he never turned around. He'd just walk in, head down, boom, right? And one time a student asked him, he said, "Sir, why do we have to know this, right?" And this is like a junior level math class. And so he stopped the class and he took the student out of the room. And then he came back like 20 minutes later. And we found out later he took him to admissions and dropped him from the class. Wow. Yeah, so but just because the student asked, but it's, he's a math major, I guess. I don't even know why he asked that question. But I'm thinking of this because after I just lashed out at y'all a little bit, I feel a little bit like like him. Like him, it's all kind of quiet in here. I'm just cranking away. Shut up,
I would call that professor an AG at that point.
Call him what?
He's justified in doing that. If you don't understand why you're doing the math, why are you doing the math?
Yeah, EKG. Yeah, no, he turned out to be awesome. Really awesome. So.
Wait, so you could drop any of us? Any kind of...
Well, I don't know if that. I don't think so. I don't think I can drop you just arbitrarily. Like, I don't think that was ethical what he did. You know, but he probably convinced the student to drop. He probably convinced him.
Because we only have so many
Yeah.
W's.
Yeah.
You're only allowed 10 W's.
Yeah.
Yes,
That couldn't have been the only thing, right?
that was it.
Really?
That was it. Yeah.
Convince them.
Yeah.
Yeah, that man's whole mouth.
Literally.
Okay, let's get to this. Let's get to this.
So are we gonna factor in the denominator?
Factor what?
Constant or repeated,
Fraction.
same powers.
Well, you can split the fraction, yeah?
Yeah, it's repeating on the bottom.
Or is that too silly?
I don't know about silly. I'm not going to say silly. Okay, so let me go through this the way I see it, and then you know, see if it makes sense to you. I look at this. It's a rational function. I have a polynomial divided by a polynomial. Now the denominator happens to be factored already. That's good news for me. I don't have to factor anything. I think about the degree. The degree of up here is 2. The degree down here, if I multiply this together, would be to the 4th power. So I don't need any long division, right? So I can actually, if I want to right now, go straight to partial fractions. As long as there's not anything else that maybe I could try, but you know what? These two are married to each other. You're not splitting these up. Like even if you break this into 3 integrals, these two are together. So no formula 17 or anything like that. Like, let's just go to the partial fractions, all right? So if I do partial fractions here, then I've got the left side is going to be this. And then that must equal, okay, let's identify the factors here. So this x squared, you can look at this 2 different ways. You can look at it as being the linear factor x being repeated, or you can look at it as a quadratic factor that's irreducible. So let me see if that makes sense. If I'm looking at that, let's say I'm looking at that as a linear factor being repeated, then what I would do is write a over x, then plus b over x squared. Do you understand what I mean by that? Like that would be if I look at it from the repeated linear perspective. Now if I look at it from just it's a quadratic that's not reducible, then I would put that x squared and what would I put on top? Bx plus c, right? Some sort of, or ax plus b. Let's do ax plus b, so, right, I would do ax plus b. Do you all see that these are the same things? Yeah. Because if I split this apart into 2 fractions, I get that, right? Or if I put those together with the common denominator, I get this. So it doesn't matter which way I go with that. It's totally up to you. I personally like this.
How does the limit works though when you add those two together and the combined total is just x squared on the bottom?
How do you add fractions?
It's a little murky.
Same denominator, right? So you have to have an x squareds in both. So you multiply top and bottom of this by x, and then you put them together.
Oh, yeah.
Right? And then they look exactly the same. All right, so I've got this, right?
Yeah.
Okay, now this is a linear factor. X plus 2 is linear, right? But it's repeated. Try not to sneeze. Okay. There we go.
Right?
Yes.
Sorry to ask, but
Sprite? What?
Yes. Oh, you said Sprite. I was like, you want to have the Sprite would help.
sorry to ask, but did you turn on the recording back again?
Yeah, I'm good.
Oh, okay.
Yeah, I muted for just a minute. All right, y'all got it? I looked at this as being a repeated linear and another repeated linear. So write that out. Now, got to get a common denominator. So I don't know, do we have, yeah, I guess we have to go through this. Okay, so I'm going to multiply this side by x squared, x plus 2 squared, and then do the same thing over here. X squared times x plus 2 squared. Plus 2, yeah. All right. Over here, all I get is my 2x squared. Keep in mind this is a test problem, right? Okay, over here, okay, when I distribute here to here, the only thing that cancels from this or reduces is one of the x's. So I have an a, I have one x, and I still have the x plus 2, and that's squared. When I go here to here, I actually get the x squareds to cancel, but I still have the b, and I still have the x plus 2 squared. When I do my third multiplication, here to here, I have the c, the x squareds don't go away, and one of the x plus 2's goes away. So I have an x plus 2. And then finally, from here to here, I get d, and then I get x squared.
So you said for the denominator, the x to the power of 2, there's like 2 different ways of writing it. That's not the case for the other part, right?
Wait, say again what?
So when we're like, I don't know the word for it, but for the denominator, x to the power of 2, you said that there's 2 different ways of writing
Yes.
it. That's not the case with the other one, right? Like.
That's right. That's right. I mean, that is a linear factor. This is not a quadratic irreducible.
Oh, yeah.
If you multiplied it together, it would be quadratic, but then it would be reducible.
Oh, yeah.
So it's repeated linear.
I see.
All right, now I'm going to go after A, B, and C. Okay, can we figure out what A is? We have to be able to kill this, this, and this. Negative 2 kills these two, but it doesn't kill that. Everyone needs to see this. This is an important problem. It's on this test intentionally. Okay? You can't get A because you cannot kill off these all at the same time, right?
Yes.
Can you get B?
If you do 0 for x.
If you do 0 for x, we should be able to get B, right? Okay, how about C? You can't get C because you would have to kill off all the other ones, and that's not going to happen. Yes?
And I guess once you show us the calculator part, can we skip like trying to solve for whatever we can?
Well, you still have to, well, you mean, can we skip you even trying to see what can kill off? Yes.
Okay.
You can go straight to, but we have to do a lot of algebra to use the calculator.
So we can only get, it looks like.
It looks like we can only get B. No, we can get D as well because we can let x be negative 2. But I'm going to just, I want this problem for me to actually use the calculator for the first time. So I'm going to not even mess with that because even right now I can only get 2 of the 4. So I'm going to go to the old method, or not the old method, the long method. What I'm going to do here is I'm going to start multiplying all this out. So this squared, I would do that times itself, right? X plus 2 times x plus 2. And I imagine that you could do that on your own. On the side, you get x squared plus 4x plus 4. Right? That's what would happen if I squared that. Not showing work. Over here, same thing. B, and then in front of x squared plus 4x plus 4. And then plus over here, this, I'm going to just take this and just distribute that through. So we get cx cubed plus 2cx squared. And my last term is plus dx squared. So there's no way around this if you want to actually use the calculator for us.
And this is called a sequence, I think. The A plus B plus C plus D. So it's X plus, no. Okay, I'm trying to understand. I understand now.
Yeah, I haven't used that terminology at all. So
You haven't.
the sequence is a more abstract general
It was
thing.
a genuine question, is it a sequence? But it's not.
All right, any questions on that line? Okay, continuing my expansion of everything. Okay, ax cubed. Take your time when you do this because if you mess one thing up, it's over.
Yeah, especially if it repeats like that.
Yeah, so you gotta be real careful. And I'm trusting y'all are checking my work here.
I feel like Cal 2 is like learning how to slow down.
Okay.
Does that mean you like your lowest math class?
Well, I mean, the lowest lowest test grade was me, so.
He's gonna beat us.
The lowest test grade, I was the one who got a 15 first time.
Expanding out. Hey, how's it going? You've missed some fireworks today.
I can see.
Yeah, no. That doesn't have anything to do with this stuff. Okay. Yes, expanding out. All right, now what I do is I collect all like terms together. So I'm going to start with the highest power of x, which is going to be 2x squared. I'm going to write the left side down. Plus 4 equals. Let me get my x cubes together. So I like to kind of underline them or something so I don't lose track of them. I've got ax cubed plus cx cubed. All right? And then now I'm going to go after my squareds. Squared, squared, squared. I think that's, oh, yeah. See, I almost missed it. That's why it's good to mark them, so that at the end you know if you've gotten them all. So 4ax squared plus bx squared plus cx squared. Oh, wait, shit, no, I already did that. That's another thing, I forgot to cancel them after I used them, get rid of them. 2cx squared, and then finally plus dx squared. Okay, I've got all my x squareds out of here. And now all the x terms, yeah, there's maybe another way that would have been faster, but I want to show you the calculator, all right? Because there's a problem that exists that I could give you where you can't get any of these. Thank you. Oh, that's not the beginning of an avalanche of sneezes. All right, so that's my x terms, right? And then I have plus 4b.
Yes.
There we go. All right. Almost there. Almost ready to use the calculator. All right, now what I'm going to do is these x cubes, I'm going to pull the x cubed out, which leaves me with a plus c with the x cubed. Now I factor the x cubed instead of out the front, out the back. And on the next one, I pull the x squareds out. But I pull the x squareds out of all of these, and I pull it again out to the right side instead of out to the front. And then here I have 4a plus 4b, and I pull the x out, but I pull the x out to the back again, and then finally 4b. I realize this is a lot of work. I realize this is tedious, but you know, this is part of the partial fractions.
My mom used to say it's part of the show.
It's part of the pleasure and joy that you experience with partial fractions. All right, so now we match coefficients. Yes?
On my notation, I've been putting all the x's in front of whatever. Does it really matter? Okay.
As long as you understand your matching coefficients. Yeah. So what I'm going to do now is I'm going to try and match coefficients. So over here, do we have an x cubed like we have here? No, there's no x cubed here. So one way you can look at it is that you have 0 x cubes, right? You have no x cubes over here. So that means that that 0 must be what a plus c is, right? So I'm going to start writing a system of equations right now. My first equation says this: a plus c must equal 0. Now I left spaces because I'm going to do a's here, b's here, c's here, d's here, equals a number. I'm going to do that for each one of these.
Do you ever do like plus 0 times the letter as placement?
Plus 0 what?
So it'd be like a plus 0 times.
Oh, you could. You could. I'm going to do that when I set up a matrix. We're going to do it. Okay, so now what I do is I take these, right? This is the stuff in front of x squared, and that has to equal this number, 2. So we get 4a plus b plus 2c plus d must equal what? 2, not 0, right? 2, this number. You with me? Yes? Okay. Got to go now match this one, right? 4a plus 4b has to match up right here and become a 4. So 4a plus 4b must be 4. And one more equation, right? 4b must be 4? 4b must be 4. Now I realized a long time ago that you could have figured out what b is a long time ago. But again, this is more for the method than it is, this problem. So we now have a system of 4 equations and 4 unknown variables. And we want a way to do this on our calculators. Okay? So what we do first is, and I'm going to bring up the notes to show you here in a second. What we do first is we convert this into what we call an augmented matrix. And we're not going to get into the big discussion about what matrices are and all that. Let's just understand what it is we're doing in terms of the mechanical part of it. All we're doing is we're writing all of the coefficients we see for A, B, C, D, and then the number that we see over here. So here we have a 1 in front of A. We have no B's, right? We have 1 C, and we have 0 D's, right? That's what we have there. So I'm just going to write over here 1, 0, 1, 0, 0. Those are those numbers across. 1, 0, 1, 0, 0, right? And I do that for all 4 of these rows. So this is 4, 1, 2, 1, 2, and then 4, 4, 0, 0, 4, and then 0, careful, 4, 0, 0, 4.
The only part of Colorado writing is calculator 4.
Yep.